Alright. Hey, now we're going to do graphing with the vertex form. So let's talk about vertex form, why this is vertex form, and what that means. So what we're going to do is we're going to start off with y equals x squared. Now that should be pretty easy. You should already know what y equals x squared looks like. I'm just going to darken my axes a little bit, and let's go ahead and put y equals x squared on there. So we're going to put y equals x squared. We got 0, 0, you got 1, 1, you got 2, 4, right? Everybody familiar with y equals x squared. It looks just like that. And that's a pretty graph right there. Ooh, that's a little bit messy on the left side, but hey, that works for the x squared. Now, we understand translations, right? We know how to move things around and flip it and make it wider and shorter. So pay attention to vertex form here. What is this going to do to my graph? When I subtract 3 from the x, what happens? Hopefully you said it moves 3 spaces to the right. And so any point on my graph is going to move 3 spaces to the right. Now what is this plus 2 going to do? Hopefully you said that makes it move 2 spaces up, because if you didn't say that, you're wrong. So everything's going to move over 3 spaces and up 2 spaces, so that's where the center point's going to be. This one will go over 1, 2, 3, up 1, 2. This one will go over 1, 2, 3, up 1, 2. Everything, even this one, over 3, up 1, 2. Same thing on the other side, over 3, up 2. Even that axis of symmetry is going to move over, right? It was right there in the middle. Now it's going to be right here. Alright, so now what we got is we got that quadratic. We already done graphed it. How about that? That's just so awesome. Now this is vertex form because of that. Pay attention, the vertex here was 0, 0, right? 0, 0, can you see that? That's because you're not adding anything to the x, and you're not adding or subtracting anything outside of the x. Therefore, it stays where it was at 0, 0. Now this vertex form, the way that it's often written in general form is y equals x minus h squared plus k. The vertex is going to be found at h comma k, right? Because h is being subtracted, so that's going to be positive, so it's positive h, which is 3 spaces to the right, and k is going to be added on the outside, which means it's right there. You'll notice that my vertex here is 3 comma 2, and there's the h, which is 3, and the k, which is 2. So pay attention to that, because that's going to make it easy for you to graph it. Now, can you still get all the other stuff from this one? Why, absolutely! We can get a y-intercept, we can get an x-intercept, we can do all those fun things. How do we get the x-intercept? Well, we make y equal to 0, right? So let's do that. Let's say the x-intercept when y equals 0, and you say, but Mr. Bywater, it don't have no x-intercepts. Well, then our equation better show that, shouldn't it? So let's go ahead. We're going to put y for 0. We're going to go 0 equals x minus 3 squared plus 2. We're going to subtract the 2 to the other side. We got negative 2 equals x minus 3 squared. We did this in our homework last night. We're going to take the square root. I'm going to take the square root of a negative. That means there are no real roots, right? No real roots. Or if you're in Texas, you say roots. Square root. All right, so there we go. No real roots for the x-intercept. Now the y-intercept, how do we get the y-intercept? For the y-intercept, we make x equals 0, and that's going to be really easy with vertex form too. We're just going to go y equals x, which is going to be 0, just kidding, minus 3 squared plus 2. So y equals negative 3 squared plus 2. That's going to be y equals 9 plus 2, which doesn't equal 2. It equals 11. So 11, there we go, would be the y-intercept, which would be up here somewhere on my graph. And that's all right. It means that my graph is okay because it's in the right place, and I would eventually get up to the 11. All right, we got the vertex, we got the x-intercept, we got the y-intercept. What more do you want? There you go. On to the next one.